All right, so we're going to revisit this energy consumption example and work the one-way ANOVA test all the way through from start to finish. So the Energy Information Administration gathers data on residential energy consumption and expenditures and publishes its findings in residential energy consumption surveys entitled Consumption and Expenditures. Independent simple random samples of households in the 4 U.S. regions yielded the data on last year's energy consumption shown in the table. At the 5% significance level, do the data provide sufficient evidence to conclude that a difference exists in last year's mean energy consumption by households among the 4 U.S. regions? So I'm going to test the claim that mean energy consumption varies by region. And then my null hypothesis is that all of these means are equal. So I'm going to write that as mu NE is equal to mu MW for the Midwest is equal to mu S is equal to mu W. And then my alternative would be not all means are equal. Right. Then that takes us to our assumptions and conditions. So we do have a random sample, and they are independent. So those two we can check off. For the normal probability plot, so since that is kind of time consuming and we've done so many of those, I went ahead and made all 4 of them. So we'll just take a quick look at them. And they look like they're all, I don't see anything shocking here. They're more or less all fairly straight lines that I could fit through each one of these. No, nothing egregious, no wild outliers. So I'm going to say that that condition is fine to proceed upon. So I'll check that off, put a little star here, and PP is okay. And then equal standard deviations. So I went in and found the standard deviation for each one of these samples, and they are not all exactly equal. But we can use that rule of less than 2. So I'll take my biggest one, which looks like this guy, 2.59, and I'm going to divide that by my smallest, which is the 1.87. Let's see what we get for that. So 2.59 divided by 1.87. So I get about 1.38, 1.39, somewhere in there, which is definitely less than 2, and so we've met this condition here. Okay, means we're good to proceed with our one-way ANOVA test. And then remember that we had already gotten this test statistic earlier when we looked at how to work this formula. So we got 6.32 as our test statistic, and then we're ready to find the p-value. So to find that p-value, we are going to use this f.dis.rt command. And then we're also going to look at how to do this with the data analysis while we're in Excel. So let's switch over so we can work on that. All right, so I'm going to start by just using the command for the p-value. Before I do that, I do need to identify a few things. So f, which is the value of my test statistic, was 6.32. I'll need to know k. Now, k is the number of populations I have, and I have 1, 2, 3, 4. And then n is my total number of data pieces. So I need to add all of these up. So I have 5 plus 6 plus 4 plus another 5 gives me 20. Okay, and then to get that p-value, I'll do equals f.dist.rt. And I do the RT because we generally always want that probability that's way out in the tail with this type of test. It's going to want my test statistic first. And it's going to want my first degrees of freedom. And that first degrees of freedom is k minus 1. So I can do k minus 1, or I could just type in the number 3. That works also. And then the second part of the degrees of freedom is n minus k. So I can do n minus k, or I could type in the number 16. And I get a p-value of 0.0049. So that is pretty small. So that's one way of getting that. The other would be to use the data analysis. So let me go over to that. And it's the very first one on the list. It's this ANOVA single factor. I'll say OK, and I'm going to highlight just the numbers. And it's fine if there's some blank boxes there. Just don't highlight the words unless you're going to click the labels in the first row box. And let's output this on the same page so we can actually take a look at it while we're here. And there's my output. So let's see. So here's my F statistic right here. And here's my p-value. Okay, so it gives me a lot of these numbers that we would normally need to do this calculation along the way. So if you were going to calculate this by hand, this table does give you all of that, which is great. But you can cut to the chase here and just grab your F test statistics. So that would round to 6.32, which is the match. And that is the same, or roughly the same p-value we have here with a little bit of rounding issue with the 6.32. It's why it's not a perfect match, but close enough for all intents and purposes. So that would be the two ways that we can do this in Excel. And let's go ahead and write up our conclusion. So we'll switch back to that worksheet. All right, so as you can see, I've already added our p-value to the paper. And that is 0.009, so less than 1%. So my p is less than alpha. And I do reject the null hypothesis, meaning that all of these means are not equal. Okay, so my conclusion is, with a p-value of 0.0094 at the 5% significance level, we do have sufficient evidence to conclude mean energy consumption varies by region. All right, and that is an example of a one-way ANOVA test.